Yesterday, I just gave you some random tables and asked you to find the rate of change known as the unit rate, and then we're learning to use the word slope. But this time I want to give you 4 of them, but put a little bit of context into each of them. Sorry about this. I'm going to try to zoom in and make it maybe just a little bigger. Does that help? I hope. So I want to talk about this. Whatever I write down, again, I'm going to ask that you write down. Hours are our x. Those are the independent variables, things we cannot control. And then miles away from home. So we're talking about distance and traveling here. We are going to do the exact same thing we did yesterday. We are going to see how does it change in terms of hours. So this would be a +3 to go from 0 to 3. We add 3 to go from 3 to 6. We add 3 again. When we look at the Y's, this person did not start at home because I know at time 0, they are already 35 miles from home. So after 3 hours of traveling, how far did they get? A couple things you could do if you're not sure of the distance of these numbers on your calculator. If you did 53 minus 35, it would tell you the difference in travel, and that is +18. Okay, then during the next measured interval, they were at 53 miles. They ended at 71. I'm curious what that is. So again, if you want to use a calculator, 71 minus 53, and I got 18 again. Notice he didn't start at 0. So then we will just do the change in the y over the change in the x. I'm going to write that down again. Change in y's. When I say change, how did this number change to get to that number? How did that number change to get to this number? Divided by the change in x's. We figured that out when we do these little arrows. We're figuring that out for us. So the change in the y was a +18. I'd like to write the sign down with it. It increased by 18 as our time increased by 3, so +3. Divide that out. They were able to go 16 miles per hour. Be sure to label. We know what that is talking about. In 1 hour, they traveled 6 miles. I'm going to give you a second. Make sure you have that all written down. It's hard for me to judge the speed when I'm in my basement and you're there. So if you need to a minute, just pause the video, except I won't put the word pause on the stuff that you're copying. But feel free to pause just to make sure you have everything written down that I do. Thanks for pausing if it was necessary. Okay, we will look at the next one. Now we have time again. That will be our x, the independent variable, something we can't control. And in terms of time, we're looking at 7 a.m., 9 a.m., 11 a.m. And then we're seeing or studying, or we noticed or counted how many donuts are at the bakery. At 7 a.m., there was 150 donuts. At 9 a.m., there was 110. At 11 a.m., they had 70 donuts. Kind of makes sense. People are buying donuts. This is called a horizontal table. It's exactly the same. So in our x's, to go from 7 a.m. to 9 a.m., that's +2. 2 hours have passed. 9 a.m. to 11 a.m. is also 2 hours, so +2. Now we'll look at what's going on with the donuts. At 7 a.m., they started at 150. At 9 a.m., they had 110. That is a decrease. The numbers are getting smaller, so I know it's going to be negative. The difference between those two numbers, again, if you need a calculator, you would do 150 minus 110 and get 40. So over those 2 hours, they sold 40. Then we're going to compare those. We start at 110, but we go down to 70. So I know it's a decrease, so negative or subtraction there. And then I subtract and I get 40 again. Well, they have constant numbers in our x's and y's. So we will do the change in y, negative 40 donuts over positive 2 hours. We end with negative 20 donuts per hour. What do you think the negative would represent here? You can't have a negative donut. Hopefully that means what? They sold the donut as opposed to the baker in the back just eating the donut. So at this rate, we're going to assume they're selling about 20 donuts per hour. Excellent. If you need, you may again pause the video. If you need to get caught up, that's okay. Thanks for doing what is best for you and pausing the video if you need to. This is a vertical table. It's written up and down, horizontal table left and right. The process is exactly the same. Independent variable is my minutes. Now we're talking about submarine. When the submarine has a negative depth, what do you think that means? A depth of a submarine, if it's in the negatives, what does that tell us? Yeah, it is underwater. Obviously, submarines are underwater. So once again, let's calculate how are my x's changing. And then please go and determine how do the y's change. You work on that. I'll silently work on it. We will compare our answers. All right, I was able to calculate mine. Did you notice when we're working in negatives, as time is going on, the submarine is getting closer and closer to the surface? The surface would be 0, so it is starting at negative 120 feet below the water, and then it's getting closer to the top. All right, again, you do the change in the y's. How are the y's changing as the x's are changing? So plus 20 feet over plus 5 minutes. When I reduce that fraction, I end up at a positive 4 feet per minute. So the submarine is slowly returning to the surface at a rate of 4 feet per minute. Excellent job. Okay, I'm going to ask you to pause and we're going to chunk this. I would like you to determine how the times are changing, and then I'd like you to determine how the temperature is changing. And we'll compare answers. Let's make sure we get the same answers there before we start calculating the unit rate here. Please pause the video. Thank you for pausing. Thanks for working really hard. And this is what I got. This is what I'm noticing. It isn't a constant change here. We have things going on. So think back to what we had to do the other day. I need to compare all of my separate changes in y's over changes in x to verify that it is actually linear and there's a constant rate of change. So I will start with negative 4 over positive 2. When I simplify that, I see a negative 2-degree change in temperature during that first set of data. Now I'm going to compare it to my second set of data. Notice if you keep yourself organized and lined up, how easy this could be. I had a change in the temperature of -6 in 3 hours. When I simplify that again, I got a negative change of temperature of 2 degrees per hour. And I'm going to verify here the next one. I had -2 degrees over a 1 hour change. That resulted again in a -2. I was able to get -2 for every change in the table. Do you remember what that means? If we were to graph it, what would that mean? It reminds me of a couple things. Let you think a minute. It's negative. What direction do you think the line would be if we were to graph it? My apologies. Downhill. That would be a nice negative. The rate of change tells me the directions of the line. Okay. The fact that they're all -2 tells me this will be linear. When we graph this in a day or two or next week, we are all going to get perfectly straight lines with a constant rate of change of -2. Please glue or tape this in your notebook. Thanks for working so hard.